All right, so good evening, everyone, and thank you for joining us today. My name is Dustin Hodgson, and I am the Director of the Office of Professional Programs within the Division of Professional Studies. I would like to welcome you to UMBC's Software Engineering's virtual open house today. Before we begin, I would like to go over a few housekeeping items. Number one, please note that the session will be recorded for quality assurance purposes. Number two, in order to provide the best experience for you and the other participants, please keep your microphone muted throughout the session. Number three, if you need closed captioning, please feel free to send me a message through the chat box. If questions arise during the presentation, please feel free to utilize the chat box to submit your questions. And these items will be addressed during the Q&A portion of our at the end of the period. In the event that we are unable to answer your questions tonight, either I or Dr. Samara will touch base with you offline. We hope that you enjoyed this presentation, and I would like to turn the meeting over to your graduate program director, Dr. Mohammed Samara. Dr. Samara?
Thank you so much, Dustin. Welcome, everyone. My name is Mohammed Samara. I'm the graduate program director for software engineering. Welcome to the open house for software engineering programs for 2021. Let's go ahead and get started. So it's important to understand what we mean when we say software engineering. Oftentimes, folks talk about software engineering in terms of computer science or information systems, or perhaps programming and coding. So for that, we will go to the most premier, most authoritative source on this subject, and that would be the IEEE, the Institute of Electrical and Electronic Engineers. And as they define it in the software engineering body of knowledge, it is truly applying engineering to the creation of software, specifically being able to carry on with the application of a systematic, in other words, there's a process in place, it's not ad hoc, a disciplined approach, so it's repeatable, and be able to quantify it by measuring metrics for both quality and quantity of output. And this is not only for the development or the construction of the software, but also for the operation of the software and its maintenance. So truly, it's the application of engineering to software as a discipline. So looking ahead and looking at the job outlook, we all know that software is everywhere. It's in our homes, in our cars, it's in our kitchen, appliances, also spans all of our work from business and commercial to government sectors, in defense, medicine, healthcare, banking, finance. More importantly, what we take for granted, and that is our devices, our data, our connectivity. If you think about it, if you pause for a moment, what fuels all of that? It's software. Software truly is the secret sauce that makes all this happen. So software engineering professionals, especially those with advanced degrees, are highly, highly sought after. In fact, if we look at the state of Maryland, just in the past 12 months or so, there were more than 29,000 positions for software engineering professionals. And what's more exciting is that the US Bureau of Labor Statistics expects an increase by 22% in the next 10 years in terms of demand for software engineering professionals. It's interesting, we're talking about software engineering today. If we roll back the clock about 10, 11 years ago, Mark Anderson from Netscape, who invented the underpinning, you can say, web by creating the browser, was famously said, software is eating the world. And he was predicting that a decade from that date, that software will become so critical to the success of many organizations. A decade has passed on, and we can see why software is so important. Looking at the median pay for a software engineering professional, it's above $100,000 per year. So software engineering professionals are highly paid. A little bit about me. I'm Mohammed Samara, a graduate of computer science from Florida Institute of Technology. I myself is a software engineer, computer scientist by both education and practice. I have worked and built many applications and information systems in my career. I also worked as an engineering manager and executive, and my experiences span being in the classroom teaching and also administration and higher education in the industry, and also doing some research. Some of the highlights of my career: Harris Corporation, I had quite a career there. Ambulance Corporation in Costa Mesa, California. I'm also very proud of being a founding member of Florida Polytechnic University College of Engineering and College of Innovation Technology. I am delighted to be a professor of practice of software engineering and the graduate program director for software engineering at University of Maryland, Baltimore County. And I'm currently doing some collaboration in terms of applied research in software engineering and data visualization with the University of Miami. So let's just pause for a moment and think about why now? Why software now, right? And when did software engineering come to become a profession, right? To do that, we really have to go back all the way to the US space program and our pursuit of putting a person or a man on.
Sorry, everybody. It seems as though we have some connectivity issues with Dr. Samra. Let's see if he comes.
Hi, can you hear me there?
Yeah, there we go. Perfect. Thanks, Dr. Samra.
Sorry about the trouble with the network there. So Margaret and her colleagues worked to show that software is critical to the Apollo 11 mission and to bringing a man to the moon. In fact, she was credited to coin the term software engineering, which is really the application of a systematic, disciplined, quantifiable approach to the creation of software. During those times, in the 60s, you can say that's a dark era because of what happened then. Software was seen as a profession for women. Men tended to work on hardware and other aspects of computing. Now, fast forward now, and we see people of all ages, genders, and disciplines working on software engineering. So much credit goes to Margaret Hamilton as a pioneer. So if we fast forward now and we see what we can do with software engineering, if we look at this device, this device for safety for children, if you look at it, what's so special about this device, right? It has a lot of communication sensors. It has a 4G radio, it's waterproof, it has a GPS radio, it has audio and video two-way calling, it has Wi-Fi, and it doesn't cost that much, under $100. But what makes it special is the fact that it has software everywhere in it. Software at the board level, the processor level, firmware, the applications themselves that the child and their parents interact with is powered by software. The connectivity to the network is also powered by software. The application itself running on the back end, it's all software. Without software, this device, as beautiful and as wonderful as it is, has no meaning and does not function. If we also look closer in the 80s, our vision of software was to place a desktop computer in every home and on every desk. Apple brought us beautiful interfaces and beautiful hardware. Some other companies innovated in terms of creating a laptop. What you see on the right there is a laptop from the era around 1985. That doesn't resemble any laptop that we have today, but nevertheless, during that time, that was a huge accomplishment. But what's really more exciting about software is the fact that many people around the world are experiencing software for the first time ever in their whole life. They're experiencing computing on a smart device, typically a smartphone or some type of smart device. In fact, if we look at the number of people that have smartphones today, that number exceeds 6 billion people. That's a coverage of about 81% worldwide. This number is expected to reach close to 8 billion in about 5 years' time, in 2026. So many people in the world will be interacting with software. So software has an impact on humanity. So now that we understand a little bit about what brought us here and what software engineering is about, it's important to understand the life cycle of software. How do you build it? How do you maintain it? How do you bring it into being? Oftentimes, folks look at this phase here, the implementation phase, which is coding and programming and actually doing the implementation itself. But there's a lot more to software than just that. And really the reason behind that is software is a reflection of a real world object or real world process. And as such, it involves many stages. It involves planning. We need to understand the problem. We need to analyze it and figure out the different options for solutions and weigh in different costs and different constraints. We also need to design it in a way that is not only just beautiful, but it's also usable, it's efficient. And of course, we need to implement it and test it and ensure that it performs correctly. And just like anything else in life that's real, although software is somewhat virtual, it needs to be maintained. It needs to be updated, upgraded, and in some cases, some parts become obsolete or perhaps they fall apart and they need to be replaced. What's really interesting about the software lifecycle is that as a software engineer, you can play different roles in this cycle. So for example, in the planning phase, there are many positions that require a product owner or product manager. As a software engineering professional, you can fulfill those roles. It's important to have analysts at different levels, people that understand the big picture, system analysts, and also someone who understands the business domain at a deep level. We talked about analysis. So the analysis is not just at the system level and the business level, you also need to analyze the data, the database and the data, the interactions, the input and output. And once you have defined the problem and you analyzed it, now you need to design a solution that's beautiful, elegant, efficient, safe, and fulfill the needs of the users. So for that, you need solution architects. And there's a great demand for that. In fact, we'll talk about that a bit later in the session as one of the pathways in the program. We also need designers who understand the system, because oftentimes when you're creating software, you're creating a system of systems. And of course, more importantly, we need to create user interfaces and user experiences that are beautiful, efficient, and usable. And it goes without saying, we also need software developers. Most people are familiar with software developers, full stack developers versus front end or back end. So oftentimes, if you have a large system, a software engineer can specialize in one aspect or another. So you can specialize in creating the user interfaces or the back end software that no one sees, or perhaps even the middle layer. There's also a rise for a position called DevOps engineer, which deals with tools and platforms that enable better utilization of the software development process. And oftentimes, to create large-scale software systems, you need multiple teams. So in those cases, you need someone to lead a team or multiple teams on a project or a product or multiple projects for that matter. So that's the implementation phase. Testing and quality is very critical to the success of any product and any venture, but particularly software because of its nature and its complexity. And it's important to realize that the software is there to fulfill the needs of the users. So it's important to verify that the software actually does fulfill the acceptance criteria for the users. So this gives rise to a quality engineer, which is also part of what you do in software engineering. And lastly, as we said, the software needs to be maintained. So over time, you need to update it, upgrade it. This is where the product owner carries on with the progression and ensures that the product as a whole, the software as a whole, stays consistent. And that involves also software developers and technical support engineers. So you can see the breadth and the span of roles around the software development cycle. And this is where software engineering trying to address. In the middle here, of course, we have the product manager who spans all these phases. So let's talk about the academic programs that we're offering at UMBC. We believe we have designed one of the most innovative applied software engineering master degree in the region, if not in the country. And I'll explain why in a moment. So we are offering both a graduate certificate in software engineering that entails 4 courses, 12 credits, and also an MPS, a Master in Professional Studies, which is 10 courses, 30 credits. And we'll talk about that in detail in a moment here. So before we dive into the actual coursework, it's important to highlight the similarities and the differences between a Master in Professional Studies in Software Engineering versus a traditional master degree in computer science. So as you can see from this illustration here, computer science tends to lean toward the theory of the fundamentals of computing, where an MPS in software engineering or software engineering in general is going to tend to lean toward the application of fundamentals of computing. And an MS in information systems perhaps is somewhere in between. So another way to look at this would be to say computer science is more analogous to natural sciences, say physics. And so we're dealing with fundamentals of computing, the algorithms, the construction of those, where software engineering really spans a breadth of things, but starts with applications, their architecture, their impact on an organization, how we sell the software, the economies of software, how we license it. There's a whole knowledge area on software licensing and the human impact, the human factors of software as well. In other words, we have to look at software as a system. We start by looking at its security, safety, and reliability. Does it perform the function intended for? How does it evolve over time? What are the legal and ethical implications? What's the cost in terms of schedule? Does it align to the organization mission? What's the context that it's trying to serve? How complex it is? And what type of compatibility issues do we need to deal with? So in other words, when we're talking about programming or coding, or some aspect of computer science, we may be building one box or one frame. But really with software engineering, we're building a whole house with many rooms and many structures. And we want this house to fit nicely and smoothly in a whole city, a metropolis, and function safely, correctly, and happily to its users. In fact, if we go back to our IEEE, the software engineering body of knowledge, there are 12 areas, 12 knowledge areas, or we can say disciplines or subfields of software engineering. At the top, the software requirements, oftentimes people call that requirements engineering. You can see design, construction, testing, maintenance, configuration management, engineering management, a very important field there, engineering process, engineering models and methods, software quality, also very important, software engineering, professional practice, and software engineering economics. All of this is built on three fundamental foundations, foundations in computing, mathematical sciences, and engineering. And this body of knowledge is a tremendous resource. Contributors are from 33 countries, more than 150 reviewers. So we are going to be offering these degrees at our main campus. Obviously, this is tailored for professionals and folks who might be working in the field. So the classes will be held in the evening. Many, if not most of the classes will have an online hybrid component to them as well to allow for more flexibility for folks to attend in terms of scheduling. So now let's talk about the program. As you can see here, the length of the program is a standard length. So in terms of a differentiation between an MPS and a traditional MS, it's not a matter of rigor or length of the program, it's a matter of focus, right? So we have 6 core courses, 18 credits, and 4 electives, 12 credits. The core courses, first we start with ethics, because in order to be an efficient and effective software engineering professional, you have to start with meaning. What we want to do is change the world. So we start with meaning, and things follow. From that, success follows and money follows. So understanding the ethics and the implications of software engineering is very critical. So that's Software Engineering 601. From there, it's important to understand how we analyze and design a software system. So that's 636, 645 is Advanced Software Engineering Topics, and 701 is a very important coursework, and that is a capstone in software engineering, So this would be a real world project. And we envision this to be a real world project in collaboration with a partner in the industry, either in the local area or in the region, solving a real world problem. And the fifth course here is Fundamentals of Software Testing. We talked about testing and quality assurance and how important that is. The sixth course is Understanding Leadership and Management and Project Management as well. So either Engineering Management 652 or IS 765. Next, I'll talk about the electives here. And so again, these are the core courses. You can see the electives and what we've done here, and that's one of the differentiators for our program, is the breadth of courses offered from our sister disciplines, from computer science, information systems, data sciences, human-computer interaction, and big data. So there's a breadth of courses here that a student can take for their electives to follow a particular pathways. And I'll talk about that in a moment. But we wanted to go back to the software development cycle and show you how some of these courses, both the core courses and also the electives, apply to these different roles that we talked about. So for a product owner, 645, the advanced software engineering topics, along with 636, system analysis and design, and 638, which is software process management, are very helpful and critical. For analysis, you can see 636, the system analysis and design course. For an architect, that same course, 636, along with human-computer interaction and design interfaces. For the implementation, several courses, including advanced software development or advanced software engineering, the capstone in software engineering, special topics in software engineering, along with electives from computer science. For software testing, that would be the 740, the software engineering and testing course. And for maintenance, both the special topics in software engineering and also our IS 800, which is software maintenance course. So you can see how these courses apply to the complete life cycle and also the different roles that a software engineer is expected to play. At the heart of this, of course, is the project manager. And for that, we identified those two courses, the engineering management course and also the project management course. Ethics is really across all these roles, across all these phases as well. So let's talk about pathways. We have identified 3 top pathways along with 2 alternative pathways that are very similar to each other. At the very top here is software architecture, and I alluded to this earlier in the presentation, that there's a high demand for software engineering professionals that understand the big picture, and they're able to create the system of systems, but also they're able to navigate the fine details. So that's one track. The other is data engineering, not to be confused with data science. So data engineering deals with the platforms, the tools, and the techniques needed to power data sciences. Data engineering tools, database tools, data transformation tools, data cleansing tools, data input and output tools, data integration tools. So there is a large number of skills and tools and techniques that are taught in data engineering. And some can argue that data engineering is as important as data science, if not more important. Third pathway is software engineering management. So that's a sub-branch of software engineering, a sub-branch of engineering management, specifically tailored for software and understanding the ins and outs and the specialties of software itself. There are many studies that show that the right software engineering management approach can lead to very successful software and information systems. The fourth and fifth pathway, having an advanced degree in software engineering allows someone to go on their own and be a consultant in the field or a trainer. And there's an overlap between these two. And in a moment, I'll show the actual coursework that speaks to these. So for software architecture pathway, advanced computer architecture goes without saying, principles of computer security, understanding computer security is critical across the board, really. Design and analysis of algorithms, and then fundamentals of human-centered computing. For data engineering pathway, special topics, this course 691, is going to allow us to really stay ahead of the field and bring in innovation as they come to the program. So we will bring in innovations in data engineering and data engineering tools to this pathway. Platforms for big data processing. This is from our data sciences track. Also special topics in information systems. And again, fundamentals of human-centered computing. The third pathway is software engineering management. You would take both the management, leadership, and communication course from engineering management and also the project management course, along with software process management, special topics in software engineering, and fundamentals of human-centered computing. And hopefully you can see this now. Every pathway, all 5 pathways, have fundamentals of human-centered computing because a user interface is critical to the success of an information system, to the success of an application. Not only it's important to have an elegant, beautiful interface, it's elemental to have the right interface. And then the 4th and the 5th pathways, as I said before, consultant and trainer, there are a lot of overlap between them. In fact, there's only one difference between the 2 pathways. This allows someone to venture on their own or be part of a larger consulting firm, if you like. And so you can see the courses there. And again, fundamentals of human-centered computing is very critical for every single pathway. The graduate certificate entails 12 credits for courses. You can see here similar courses borrowed from the core courses from MPS 636, Structural System Analysis and Design, Advanced Software Engineering, the capstone, and also fundamentals of software testing. Coursework in the certificate can be applied toward an MPS, but we highly believe that an MPS can take an individual to the next level. It can take a very successful engineer or a new graduate into new heights. So hopefully that gives you quite a bit of background there. Kind of to step back a little bit, software engineering is important. Writing code is important. But the creation of a software system is the reflection of a real-world object. So that really involves many more skills, many more tangible skills, professional, workplace type of skills. Communication, very effective communication, both verbal and writing. When you hear or read effective communication, you know it. So that makes a huge difference. Teamwork and collaboration, both for teams that are co-located and teams that are distributed or remote. And the last 18 months give new meaning to working with remote teams. Problem solving, that's fundamental for any engineering discipline, but particularly for software. We want to be able to think inside the box, outside the box, and beyond the box, and come up with creative solutions, and try new things that have not been tried before. Having very much close attention to detail to the point of being obsessive, not necessarily seeking perfection, but not being content with good enough or even very good. Shooting for excellence in everything we do, that produces highly efficient software systems. And of course, being able to actually implement it and having those technical skills to program and code is critical to the success of a software engineering professional. And these are the skills we will emphasize and re-emphasize and reinforce in our coursework. We are lucky and fortunate to have a wonderful faculty advisory board who's advising this program, who brings many years of experience in the practice and in research. So we have the advantage of bringing cutting edge research and practice into the program and bringing that forward. And I talked about some of the special topics courses and how we plan on doing that. So moving on then, logistics in terms of admission requirements, a bachelor degree with GPA of 3.0, also some level of programming experience, either program course completed in the past 10 years, or a substitute would be professional industry experience. Applicants who do not have that would be asked to take IS 147 or 247 or the equivalent computer science course 201 or 202. Another requirement is college level calculus math course, the equivalent of Math 151, which is calculus, or Math 155, which is applied calculus. GRE scores are not required for students who are non-native speakers of English. English proficiency test scores are required as well. The application process is fairly simple. We ask you to submit 3 things: official copies of your transcripts and English scores if applicable, statement of purpose, which I will talk about in a moment, and your professional resume, along with $50 application fee, which can be waived by using the special code that we have here on the screen. So to apply, you can go to gradschool.umbc.edu/admissions/apply. So that is the application process. And a little bit about the statement of purpose. We expect the student to describe their background, why they're interested in software engineering as a discipline, why they're interested in us, University of Maryland, Baltimore County, and how they meet the requirements. And as we conclude here, it's important to understand how important software engineering and software to the innovation and the advancement here locally, regionally, in our country, but also in the world. And so this is a journey that we're taking together. And really the software in many ways is that invisible hand, invisible writing that really whispers these stories and possibilities to the world, to our surroundings, to the hardware. And you and I and we can be those storytellers. With that, we conclude. We will open the floor for questions. Thank you so much for being with us tonight. Dustin, I will hand it over.
Great, thank you. Thank you, Dr. Samra. So if anybody has any questions, feel free to, at this point, we have two prospective students, so it seems to me that we can have everything just verbally asked. So feel free to engage with Dr. Samra. He's here to answer any of your questions. So please feel free to unmute yourself and feel free to ask the questions.
Sure, happy to take any questions or any comments or any remarks.
Okay, Mani, I think you're on mute, I think.
I'm on mute. Can you hear me?
Yeah, there we go. There you go.
It's the mic. I'm sorry. I wanted to thank you for the time you're taking with us. I really appreciate it. And the presentation was super informative.
Well, thank you for being with us. I'm glad you were able to make it. I know it was a last notice there when we sent you the email.
Absolutely. I dropped everything to make sure I could attend.
Oh, thank you. That's so kind. I'm happy to hear that.
I had a question about 2 slides ago. You were saying the GRE is not required. Does it have any effect on admissions? Because I notice, especially because of COVID, more schools are not requiring the GRE, but I was still planning to take it anyway. But what effect, if any, does it have on the admission process?
Right. It's helpful to have the GRE scores. So if you are planning on taking the test, or if you have taken it, submitting the scores are helpful. We do not take it as an absolute measure for an admission requirement. We understand the difficulty that students are having with, conducting tests during these difficult times. Mm-hmm. So we want to make it as easy and as convenient, and also we want to make it fair and equitable. Some students may be able to attend a testing center while others are not, because they're in different, region in the country, in the U.S. or perhaps overseas. Mm-hmm. Certainly, providing your GRE scores, obviously, if they are very favorable, is helpful, but we don't take it as an absolute criteria for admission or lack of admission.
Okay, thank you.
You're very welcome.
Another question I had is, will these slides be available after this presentation?
We can certainly make them available.
That'd be awesome.
Yes. Amani, what we'll do is actually when there will be an opportunity for us to follow up with each and every person who's registered for the talk here, and that's why I asked for your personal details there. So happy to make sure that we send you the slide deck and this presentation because we're recording it as well.
Wonderful. Good to hear. That covers most of my questions. It was really nice hearing the presentation, and a lot of what you were talking about really hit home, and it hit a lot of my beliefs as to what I believe software engineering is and what it can be. And it sounds like something I want to do with my life.
Wonderful. We would love to have you with us. That's great.
So Vadilia, do you have any questions for Dr. Samara?
No, it was good.
Thank you. We appreciate your time.
Yeah.
Okay, with that being said, since there's no further questions, I want to once again thank you guys for giving us this opportunity to meet with you today, and we appreciate you carving out some time to chat and attend this meeting. We'll follow, like I said, we'll follow up with further details in terms of the slides and the actual presentation in an email to you guys in the near future. And if you have any questions, feel free to reach out to myself or Dr. Samara in the future.
Wonderful.
We wish you the best.
Thank you so much.
Thank you guys so much, Mani and Viladia. Thank you so much. Have a great night.
Yeah.
Have a lovely evening.
All right, take care. Have a good night.
Bye-bye.
Bye-bye.